Hi everybody, today we are going to study calculus of finite differences. In that, the calculus of finite differences deals with the change in the values of the functions in dependent variables due to change in independent variables. That means if you consider a function y is equal to f of x, y is our dependent on x. So y will be our dependent variable and x will be our independent variable. Now in independent variables, if we make a changes, we will get a change in dependent variable. Assume that if you are making a table of a function y is equal to f of x due to changes in x. So if you consider value of x as a x naught, the value of y will become f of x naught, which we consider as y naught is equal to f of x naught. Similarly, for x1 it will be y1 is equal to f of x1. For x2 it will be f of x2. So y2 is equal to f of x2. And for xn, f of yn is equal to f of xn. And here in this unit we are considering the difference in between x1, x0, x2, x1 or xn, xn minus 1 is the same. That means here difference between x1 and x0 is h, x2 and x1 is also h. Here after x2 it is x3, x3 and x2 difference will be h. So we can write a general formula as xi is equal to x0 plus ih, where I is equal to 1 to n. And if we want to find the value in between x0 to xn, if you consider it as a x, which is an intermediate value, we required some methods of finite differences, which we will study in this unit. Now here first point in that is a finite difference. Now in finite differences, the consecutive values of x be a plus h, a plus 2h up to a plus nh, which are n values of x, n plus 1 values of x, and values of y of f of x corresponding to the values of x. That means when we changes x, we will get the values of y which are considered as f of a plus h. For a it will be f of a, for a plus h it will be f of a plus h, for a plus 2h it will be f of a plus 2h, and for a plus nh it will be f of a plus nh, where a is the starting value and h is the step size. That means interval in difference in between first and second value is h, or second and first value is h. Okay, second and third and second value is h. Okay, which is same in each consecutive pairs. Okay, now if you consider the first, or then we can write f of a minus f of a plus h, comma f of a plus 2h minus f of a plus h, up to last it will be f of a plus nh minus f of a plus n minus 1 h, are called the first difference, are called the first difference of function y is equal to f of x. That means, and we denote it by del. So here, and it is called as forward difference operator. Forward difference operator. This notation del is known as forward difference operator. Okay, so in general, the first forward difference is defined by del f of x is equal to f of x plus h minus f of x, which is our first forward difference. Next, the second, the difference of the difference of first forward difference is called second forward difference and denoted by del square. So in general we can write del square of f of x is equal to del of del f of x. Okay, so it can be written as del of del f of x, which is equal to del of f of x. It is del f of x is f of x plus h minus f of x. So here it can be written as del f of x plus h minus del f of x. We have to operate del on both functions. So del f of x, which is our difference between f of x plus 2h minus f of x plus h, and del f of x is f of x plus h minus f of x. Okay, here the difference del f of x is f of x plus h minus f of x. So from this we can also find del f of x plus h. We have to replace x by x plus h, so it will become f of x plus h plus h. Here x is replaced by x plus h, so x plus h is x plus 2h and minus f of x plus h. Okay, so here we get f of x plus 2h minus f of x, which is equal to f of x plus 2h minus f of x plus h. Here we have to make sign changes. It will be minus f of x plus h and minus plus f of x. So which will gives us f of x plus 2h minus, here f of x plus 2h, f of x plus h is twice and with same sign, so minus twice f of x plus h, and last term is f of x, which is our expansion of del square f of x. Okay, so in general we can write, and for third difference similarly you can find del raised to cube of f of x as del of del square f of x, which is equal to del square f of x is f of x plus 2h minus twice f of x plus h plus f of x. Okay, where which is a 2 is a constant here, so when we applying del operator it will be del f of x plus 2h. Here 2 is constant, so we can take 2 constant up outside the operator, 2 into del of f of x plus h plus del f of x. So which will gives us, now this will be f of x plus h. Here f of x is x plus h minus f of x. For f of x plus 2h we have to reply x by x plus 2h. So it will be x plus 2h plus h, which is x plus 3h. So here it will be f of x plus 3h minus f of x plus 2h, which is our first term calculation, minus 2 into del f of x is f of x plus 2h minus f of x plus h, and plus del f of x is f of x plus h minus f of x. Okay, which is equal to, removing the bracket terms, f of x plus 3h minus f of x plus 2h. Here it will be minus twice f of x plus 2h minus plus twice f of x plus h plus f of x plus h minus f of x. Okay, so which will gives us f of x plus 3h minus 3 f of x plus 2h minus plus 3 f of x plus h minus f of x, which is our formula for del cube f of x. In general, del raised to n f of x, del raised to n f of x is equal to del raised to n minus 1 f of x plus h minus del raised to n minus 1 f of x. Okay, which is our general formula for del raised to n f of x. Okay, this is all about our forward difference operator. Now we have to construct a table for forward difference table. So here first column is the values of x, second is y is equal to f of x, or you may write only y. Third is our first difference del, and second is our del square difference, third will be del cube, and so on. Okay, so this will be our differences. So for value of a, our first function is f of a. For a plus h, it is f of a plus h. For a plus 2h, it is f of a plus 2h, and so on up to a plus nh, it will be f of a plus nh. Okay, so here the first difference is of these two values, f of a plus h minus f of a, which is denoted by del f of a, which is equal to f of a plus h minus f of a. Next, this is our second difference, which is del f of a plus h, del f of a plus h, which is equal to f of a plus 2h minus f of a plus h. We will make some changes here. If you consider here a plus 3h, it will be f of a plus 3h. So difference is del f of a plus 2h, which is this first one, which is equal to difference of f of a plus 3h minus f of a plus 2h. Okay, if we consider here 4, a plus 4h, so it will be difference of these two, f of a plus 4h and a plus 3h, which is defined by del f of a plus 3h, which is equal to f of a plus 4h minus f of a plus 3h. Okay, which will give our first difference table. Okay, and we have to write the values of first difference in between first, second here, second, third in front of its center, and for same, or you may write in front of first also. Here second, it will be our second here difference del f of a plus h. We will see in examples how to write it. Next, here if you consider del square, second difference, so which will be difference of first here difference in between these two, del f of a and del f of a plus h, which is del f square of f of a, which is equal to f of a del f of a plus h minus del f of a. Okay, next second here it is del square f of a plus h, which is equal to, it is difference of del f of a plus 2h minus del f of a plus h. Next third here del square f of a plus 2h, which is first this, which is equal to difference del f of a plus 3h minus del f of a plus 2h. Okay, so this is our second difference table, and so on up to last. For third del cube, it will be the difference of these two, which will be del cube f of a. So first which we have calculated is equal to del square f of a plus h minus del square f of a. So we have to take the difference in between del square f of a plus h minus del square f of a. Here it will be difference of del f of a plus h is equal to del square f of a plus 2h minus del square f of a plus h. Okay, so in this type we have to make a forward difference table. Okay, So this was all about forward difference table. Now next is backward difference. Now the differences f of a plus h minus f of a, comma, f of a plus 2h minus f of a plus h, comma, up to f of a plus nh minus f of a plus n minus 1h, okay, are called backward difference operator. Backward difference operator, and denoted by deba. So here first difference is deba f of a plus h. It says deba f of a plus h, comma, second difference is deba f of a plus 2h, comma, third up to so on, last difference is del f of a plus nh, okay, respectively. Now so that the first difference deba f of x can be defined in general. In general you can write deba f of x plus h, deba of f of x plus h can be written as f of x plus h minus f of x, okay. Or you may write deba f of x is equal to, here f of x plus, and which is equal to del f of x. Here in del f of x we have to subtract x plus h term, f of x plus h, from f of x, and in deba it is notation is denoted as, or it is written as deba, okay. So here deba f of x plus h is equal to, we have to subtract function f of x plus h from its previous f of x, okay, and in del f of x we are subtracting f of x plus h from itself function, okay. So f of x can be written as, we have to write f of x minus h, we have to take f of x plus h can be, it is first function, so deba f of x is f of x, and its previous function is f of x minus h. So deba f of x is equal to f of x minus f of x minus h. Second difference is given by deba square f of x, which can be written as a deba f of x, which after calculation, or if you find it, deba of f of x minus f of x minus h, which is equal to deba f of x minus deba of f of x minus h, which can be written as deba f of x is f of x minus f of x minus h, minus into bracket deba f of x minus h, we have to subtract f of x minus h from its previous, which is minus f of x minus 2h, okay. Or you have to replace x minus h in this function, x minus h minus h is minus twice h, okay, which is equal to f of x minus f of x minus h minus f of x minus h minus minus plus f of x minus 2h, which will gives deba square f of x as f of x minus twice f of x minus h plus f of x minus 2h, okay. And in forward it was opposite, it was start from f of x plus 2h minus twice f of x plus h, and last it was f of x. In DABA it will start from that function f of x minus h, and after f of x minus 2h. Similarly, DABA cube f of x can be written as, I will directly write, it will be f of x minus 3 f of x minus h plus 3 f of x minus 2h minus f of x minus 3h. Okay, is a formula for DABA cube f of x. Okay, and in general, DABA raised to n f of x is equal to DABA raised to n minus 1 f of x minus h. This is all about forward and backward. You can prepare similar table as a for backward difference table also. Okay, I will show in a book. So here it is the same as similar as a forward difference. So in that, first here it is a f of a, and first difference del DABA f of a plus h is equal to f of a plus h minus f of a. Okay, for second, here difference in between, first difference in between a plus h a plus 2h, it is given by DABA f of a plus 2h minus f of a plus h. And in second difference, it is a DABA square f of a plus 2h is equal to f of a plus DABA f of a plus 2h minus DABA f of a plus h. This minus this. Okay. Similarly, we are getting third difference also. Okay. This is a table for backward difference table. Next point is properties of difference formula. In that, first, the difference of constant function. The difference of constant function is 0. QR 0. That is, del of constant is always 0, where c is a constant. Okay. Second property is del c is equal to c del. Okay, which is commutative. Del is commutative. Del is a commutative in its operator as regards constant when c is a constant. Okay. So for that, if you consider the proof of this, del c of f of x can be written as del c of f of x is equal to, it can be written as c f of x plus h minus f of x, which is equal to c f of x plus h minus c f of x, which is equal to, it is a formula for c del f of x. Okay, so del c of, that is, del c is equal to c del. Okay, constant, if you apply inside the operator or outside the operator, is a same. Next, third remark is a del f of x plus gx is equal to, it is distributive, which means we can apply del f of x plus del g of x. So del is distributive. Similarly, you may write for DAB also. Next, fourth, del a f of x plus b g of x can be written as a del f of x plus be del g of x. Okay. Next, fifth property, which is a linear indices law. That means if we consider del raised to n into bracket del raised to m f of x, which is same as del raised to n plus m f of x. Okay, or m plus n, del raised to m plus n f of x. Next, sixth product rule, that means del of f of x into g of x, which we have to prove here, is equal to f of x plus h into del g of x plus g of x into del f of x. So for that, if we consider proof of this sixth part, consider del f of x into g of x, which can be written as, so here f of x is f of x plus h minus f of x. So it can be written as f of x plus h into g of x plus h minus f of x into g of x. Okay. Here we multiply and add the terms f of x plus, here first term as it is x plus h into g of x plus h. We want here f of x plus h into del g of x. So we need minus, here we take f of x plus h, we want to take a common, and here we require the del g of x. So we will make an adjustment f of x plus h into g of x minus plus, we have to add this term again, f of x plus h into g of x minus f of x into g of x. So from first to, f of x plus h is a common term, and into bracket it will get g of x plus h minus g of x. Plus in second and third, g of x is a common term, and in bracket it is remain f of x plus h minus f of x. So we will get f of x plus h. This calculation is del g of x plus g of x into this calculation is del f of x. So we get del f of x into g of x is equal to, formula is f of x plus h into del g of x plus g of x into del f of x. Okay, which is our sixth identity or sixth property. Now for seventh, you have to prove that del f of x upon g of x, it can be written as del f of x upon g of x can be written as f of x plus h minus f of x, f of del, so we have to write first f of x plus h upon g of x plus h, and we have to take minus f of x upon g of x. We make here LCM, it will gives us f of x plus h into g of x minus g of f of x into g of x plus h divided by multiplication of this both g of x into g of x plus h. Okay, which is our denominator. Now in numerator we have to make an adjustment as f of x plus h into g of x. We have to subtract f of x into g of x, and we have to add f of x into g of x minus f of x into g of x plus h, which is our adjustment here is we have to add and subtract f of x into g of x in numerator, and denominator as it is g of x into g of x plus h. So here from first to it will be g of x common, and it only remain f of x plus h minus f of x, and in second term f of x is common and it remained, we have to take minus common so that it will be g of x plus h. Negative term we can write first and positive term second, divided by g of x into g of x plus h, which is equal to g of x into del f of x minus f of x into del g of x divided by g of x into g of x plus h, which is our formula of del f of x upon g of x. Okay, so which is our required proof. Okay, so for today we will stop here. In next lecture we will go on relations on del, deba and e, which is our shift operator, next third. Okay, thank you.